Hi everyone, we are from Team 2. We will explain to you guys about question 1 for Team Assignment 2.
At 40 degrees Celsius, humid air is enclosed in a 2-liter flask. The flask is slowly cooled. When the temperature reaches 20 degrees Celsius, drops of moisture become visible on the flask wall. Although the pressure in the flask changes when the temperature drops, it remains close enough to 1 atm for the spectrometric chart to provide a close representation of the behavior of the system throughout the process. Use the chart to solve the following problems. This is a process flow diagram. So we have state 1 and state 2. All this information is get from the question. The basis of this question is 2 liters of humid air in a closed system at 40 degrees Celsius. Reference state is water, liquid, 0 degrees Celsius 1 atm, dry air 0 degrees Celsius 1 atm. We can get the dew point temperature, which is 20 degrees Celsius from the question, and the dry bulb temperature, which is 40 degrees Celsius. A. What were the relative humidity, absolute humidity, and wet bulb temperature of the air at 40 degrees Celsius? First, we need to find the absolute humidity. Because we have the dew point temperature, which is 20 degrees Celsius, and the dry bulb temperature, 40 degrees Celsius. Because this is a cooling process, so we will have a horizontal line. The horizontal line will be intersect with y-axis, which is the absolute humidity. So we can get a absolute humidity, which is 0.0148 kg water vapor per kilogram dry air. We're going to find the relative humidity. We also have the dew point temperature and the dry bulb temperature. So we are going to use the 40% relative humidity and 30% relative humidity. We are going to find the purple line, and in order to find the purple line, we need to have a perpendicular line in order to get the dry bulb temperature. So we will have a dry bulb temperature which is 37.6 degrees Celsius and another dry bulb temperature which is 40.4 degrees Celsius. By using interpolation, so we can find out the relative humidity, which is 31.25%. We are going to find the wet bulb temperature of the air at 40 degrees Celsius. So we will have the dew point temperature and the dry bulb temperature in a horizontal line. So we need to find the wet bulb temperature. We need to extend the line, the black line here, until we get the wet bulb temperature. So the wet bulb temperature is 25.5 degrees Celsius.
Question B. Calculate the mass of the water in the flask. First, we need to draw a line for 40 degrees C and 20 degrees C on the dry bulb temperature which is have given in question, and a line parallel to it so we can find a point of purple line. Draw a purple line that have same angle of the humid volume, and we get dry bulb temperature is 47 degrees C and Y, which is the one we need to find. Next, use also the information of humid air and dry bulb temperature on 0.9 and 0.85 meter cube per kg dry air. Use the information to do interpolation to find humid volume. At dry bulb temperature is 47 degrees C, and we get the value of Y, which is 0.9074 meter cube of humid air per kilogram dry air. In order to find mass H2O, we use the value of 2 liter humid air given in the question and do some conversion of liter to meter cube, also the value of Y divided by it, and multiply with value of moisture, which is 0.014x kilogram H2O, and we get the answer value of mass is 3.26 exponent -5 kilogram H2O.
For part C, the question asks us to calculate the enthalpy change in joules undergone by the A in going from 40 to 20 degrees Celsius. So first, we draw the two vertical lines at 40 and 20 degrees Celsius respectively. We can get the enthalpy from the chart by drawing a straight line along the enthalpy axis, which will intersect with the dry bulk temperature axis. Then we will get the enthalpy at 40 degrees Celsius is equal to 79.5 kJ per kilogram dry air. Same goes to the enthalpy at 20 degrees Celsius, we will get 58 kJ per kilogram dry air. Next, we have to find the enthalpy deviation because at 40 degrees Celsius, the air is in the superheated region. So we draw a curve at 40 degrees Celsius and we let enthalpy deviation is equal to Z and use the interpolation method by using the value of the enthalpy deviation and also the dry bulk temperature. Then we will get enthalpy deviation is equal to negative 0.6484. We substitute the value of H2 hat and also H1 hat enthalpy deviation into this equation. Then we will get delta H hat is equal to negative 22.1484 kJ per kilogram dry air. Next, we find the mass of the dry air by multiplying the mass of the water vapor we obtain from part B with the inverse of the absolute humidity. Then we will get the mass of the dry air is equal to 2.2027 times 10 power negative 3 kilogram dry air. After that, we substitute the value of the mass of the dry air and also delta H hat into this equation. Then we will get the value of the delta H is equal to negative 48.79 joules.
The last question is, write an energy balance for this closed system process taking the wet air in the flask as a system and use it to calculate the heat in joule. This must be transferred from the air to increase the cooling. Assume ideal gas behavior. First, we need to give assumption, which is the system is in steady state. Assume ideal gas behavior, delta EP, delta EK, and W equal to 0. After that, we write the energy balance equation, which is delta EP plus delta EK plus delta U equal to Q plus W. Since delta EP, delta EK, and W equal to 0, so we cancel. Equation is become Q equal to delta U and Q equal to N delta U hat. After that, we need to calculate the N total, which is NDA plus NH2O. So the N total equal to the mass of the dA divided with the molecular weight of dA and multiply with the conversion factor, and plus the mass of the H2O and divide with the molecular weight of H2O and multiply with the conversion factor. All unit is cancelled out and N total become 0.0778 mole. Next, delta H equal to delta U plus N total RT. So we put all the value inside this equation. We get delta U equal to negative 35.F53 joule. And the question need to calculate the heat in joule. So Q equal to delta U and Q equal to negative 35.F53 joule. That's all for our team. Thank you.